Hey guys, this is the video for section 1.2 in our geometry book, and we're going to talk about measuring line segments. And remember, you can pause the video anytime you need to catch up. And I'm working on making them a little more fun and exciting, but right now I'm just trying to get them made. So, I know they're a little slow, but there's some fun stuff on here. There's some good word problems that we're going to be just looking at and seeing how they work. So, we'll start with a plumber's apprentice needs to cut a 54-inch length of pipe so that one piece is twice the length of the other piece. How far from the endpoint X should the apprentice cut the pipe? So this red line right here would be, okay, where should that red line be? Where should he cut the pipe so that one piece is twice the length of the other? We are going to come back to that problem. We're going to come back and after we look at a few notes. So let's take a look at this one down here. It says the measure of a line segment is the distance between the two endpoints. So if we're trying to measure how long this line segment is, we got to find out how far it is on our ruler. So from 16, 17, 18, 19, 20. So you got 1, 2, 3, 4, 5, 6, 8, 9. So from point A to point B is going to be 9 centimeters. So there's a couple of ways that you could write these. So you could write it as the measure of AB, little m stands for measure. The measure of AB would be equal to 9 centimeters or 90 millimeters. Each centimeter has 10 millimeters in it. You could just put simply AB equals 9 centimeters without a little symbol on the top. It's still that means we're looking for a measure, and that's 9 centimeters or 90 millimeters. And you can also put the little line segment on top, that segment AB equals 9 centimeters or 90 millimeters. So you could write it any of these ways. The top two are more likely when you're talking about equaling in a numbers. The bottom one is more when you're comparing it to another segment, you would use the line segment on top. So that's measuring line segments. Again, pause anytime you need to. The distance between the 2 points. To find the distance between 2 points, we can simply subtract the 2 endpoints and take the absolute value of that number. Distance is always positive. Distance always positive. You can't have a negative distance. You can't walk a negative amount. Even if you walk backwards, you're still walking somewhere. So distance is always going to be positive. That's why we use the absolute value. So if you subtract the two numbers and you get a positive, the absolute value is going to keep it positive. If you subtract the two numbers and get a negative, the absolute value is going to make it positive. The distance is always going to be a positive number. So in our problem that we just looked at with the plumbers, or not with the plumber, with the ruler at the bottom, if I took the 16 and subtracted the 25, those are my two endpoints. If I subtract them, and the absolute value would be 9 centimeters. All right, and 25 minus 16 would be the positive 9, and that would still be the absolute value of 9. This would be the negative 9, absolute value of 9. So, example of finding distance. Now, let's look at this ruler. Let's look at the points. We got points Q, R, and S. Point Q is at the 1, point R is at the 3, point S is at the 7. Find the distance between Q and R. So the distance between point Q, which is the 1, and point R, which is the 3, would be the absolute value of 1 minus 3, which is the absolute value of negative 2, which would be 2. The distance between Q and R is 2. And I know you can count that, 1, 2. So just showing you how the distance formula, how the distance works here. Find the distance between R and S would be the 3 minus the 7. Absolute value of 3 minus 7. And you could go 7 minus 3. As long as you're doing absolute value, you're going to get the same answer. Absolute value of negative 4, which would be 4. Find the distance between Q and S would be 1 minus 7. So it would be the absolute value of negative 6, which would be 6. Now it says find QR plus QS. Now we just found out that QR, from Q to R, we just found out it was a 2. So this is a 2. Plus, we find out RS right here. RS was a 4. So 2QR plus RS would be a 2 plus a 4. That's going to equal 6. And if you notice, QR plus RS is going to equal to the same thing as Q to S. So QR plus RS really equals QS. So that's going to come up in a minute. So if you take a look at this right here, it says QR plus RS really comes out to equal QS. This is called segment addition. When you're adding the two segments, you're adding the QR plus the RS. That's one segment, that's a second segment. You add them together and you get the big segment, QS. It's called segment addition, also referred to as the segment addition postulate. Again, pause that and you can copy that down. Now the segment addition basically says this as the postulate. If A, B, and C are collinear, and we talked about collinear yesterday, collinear means they're all on the same line. So if I was to draw a picture with A, B, and C on it, if I've got A and B is between A and C, here's B, okay, and here's C. If they're collinear and B is between A and C, then this piece right here, this AB plus this piece BC is going to equal the whole thing of AC. This piece plus this piece is going to equal this whole piece right here. So that's what this is telling us right here. AB plus BC is going to equal the whole thing. Alright, let's go back to our initial problem. Remember the plumber? Remember this picture we had earlier? This is the plumber's pipe, and he needs to cut it so that one piece is twice as much as the other. So we're going to figure out what we have. First we have is this piece right here, which we don't know how long that is. We don't know where we're supposed to cut it. So that's going to be our X. We know that this piece right here has to be twice as much as that X, so we're going to put 2X. And then we know that the whole thing from X all the way to Z, they gave that to us, is 54. So you're going to add your like terms and get 3X equals 54. And you're going to divide by 3. And you're going to get X equals 18. So if I was to cut it right here, this would be at the 18-inch mark. So this would be 18 inches. If I double that, if I do 2 times 18, I'm going to get 36. If I add these two together, you'll get your 54 inches. This right here is called segment addition. This is called the segment addition. And then we would combine like terms. So I would call it CLT, combining like terms, and then you're going to do your division property. And you'd have your answer of 18. You try one. So see if you can pause the video and give one a try. See if you can get this one right before I do it for you. Alright, let's draw a diagram. It says points A, B, and C are collinear with C being in between point A and B. So let's draw a little picture here. And again, hopefully you tried it on your own first. And then you pause the video and you tried it. So let's put C in between A and B this time. And it says AC is 3/4 of CB. So let's write our segment addition first though. AC plus the CB is going to equal the AB altogether. Let's plug in what we know. We know that AC is 3/4 of CB. So AC is 3/4 of CB, so it's going to be 3/4 of X. Because we really don't know what CB is yet. That's going to be our X. So it's going to be 3/4 of that X. And the AB, it tells us, is 14. So 3/4 X plus 1X, which I could change to 4/4 X. 4/4 is the same as 1. So you're going to get 7/4 X equals 14. I'm going to multiply by 4 on both sides. So I get 7X equals 14 times 4 is 56. I'm going to divide by 7, and you're going to get X is 8. So that means that X, which is X was our CB, was 8. This was CB. So this piece is 8. AC is what we're actually trying to find though. We're trying to find AC. So we're going to take 3/4 of this CB right here. AC is 3/4 times the 8. This will cross cancel a 1 into a 2, and 3 times 2 is going to give you a 6. So I took 3/4 and I put an 8 right here and multiplied across, or cross canceled, and I got 6. So this piece is 6 right here. Again, pause it if you need to catch up. Okay, midpoints. If our plumber that we were talking about earlier didn't need to make it a 2/3, I mean one piece smaller, half as much as the other, but they needed 2 equal lengths out of the 54-inch pipe. The point where we would cut the pipe would be called the midpoint. So if he wanted the pipe to be cut exactly in half, that's the point that's called the midpoint. The midpoint divides a segment into 2 equal pieces. If they're both 27s, then you know you have the midpoint. If you've got 3 collinear points and these 2 pieces are equal to each other, if this piece equals this piece, then you know that this point that was in the middle has to be called the midpoint if the 2 pieces are equal. So basically what a midpoint does is it cuts it in half. Midpoint cuts a piece in half. Again, pause to catch up. I just don't want the video to be too long. Okay, here's an example of finding or using a midpoint. NASA contracted for the development of the space shuttle in 1972. Okay, so here's 1972, here's NASA constructing the space shuttle. After 4.5 years, the project was halfway completed when the Enterprise began flight tests. So here's the flight tests right here. Put the shuttle on there, and they were testing it. That was 4.5 years after 1972. Use the segment below to determine the year that Columbia was launched. So we know that DE has to equal EC. The reason we know that is because it says halfway. So we know that point E is the midpoint. So we know that if DE is 4.5 right here, and then EC has to also equal 4.5. So this piece right here is going to be 4.5 as well. So 4.5 times 2 of them, because you've got a 4.5 here and you've got another 4.5 here, that's going to give you 9 years. 9 years. So from 1972, if you add 9 years, you're going to 1972 plus 9 years, you're going to get 1981. Oops, not 1800s. 1981. So that's what this piece is going to be right there, 1981. Okay, so 1981. Now here I put that DC, this whole piece, is equal to 2 of these DEs, because they're both exactly the same. So that's another way you could have solved it, is that DC is going to be 2 of these DEs. You got a DE here, and you'd have another DE here, because they have to be the same. So you could have used this formula, or you could have used the way I solved it there. Okay, the midpoint formula. So if we do have both endpoints, if the coordinate of point A is little a, and the coordinate of point B is little b, the coordinate of the midpoint of that segment AB is going to be A plus B over 2. All you have to do is add the 2 endpoints. This is an endpoint. This is another endpoint. You add the 2 endpoints, divide by 2. That will give you the midpoint. So that'll give you the middle. The 2 endpoints added together equals the midpoint. So, here's an example of how you could use that formula. Chris wants to attach a picture hanger at the center of the frame's length. Where should he attach the hanger? So he wants to find the center. He knows that this point starts right here at 3. He knows that this one is right here at 10.5. So he's got a 3 for one endpoint. He's got a 10.5 for the other endpoint. So if he takes 3 plus 10.5 and divides it by 2, he'll get the exact midpoint. He'll get the average, or the middle. So it's going to be 13.5 divided by 2. And in this case, the exact middle point is going to be 6.5. 6.75. When you divide these by 2, 13.5 divided by 2, you get 6.75. So the middle point is right here at 6 3/4. It's going to be right there is where the middle would be. Middle of the picture frame. That's where you'd want to put the hanger. So that's how a little application of the midpoint formula. Finding two endpoints, dividing it by 2 will give you the exact middle. Last one are just a couple of practice problems. I would pause the video now, try them yourself, probably get them all right. They're pretty easy. And then you can see if you got them right when I give you the answers. I'm going to do them right now. So pause your video if you want to do it on your own. Not, then watch me do it, but try to do it on your own first because it'll help you learn it. All right, so hopefully you tried. B to C. B to C is this right here, from here to here, B to C. -2 minus 1, I mean, you could still do your subtraction. -2 minus 1, your absolute value, it's going to be -3. Absolute value of -3 equals 3, and you could have counted 1, 2, 3. That's how far it is. From A to D, so from -3 to 2, it would be -3 minus 2. So you'd have absolute value of -5, which would be a 5. And you could have counted 1, 2, 3, 4, 5. And from E all the way back to A. So you're starting at E, which is a 4. You're subtracting A, which is a -3. So 4 minus -3 is going to be a 7, because you're going to make these both pluses. And you're going to get a 7. So that you could have counted 1, 2, 3, 4, 5, 6, 7. Now find the midpoint of each segment from B to D. So point B is -2 plus point D is +2, and then divide by 2. So you would get 0 divided by 2. Your midpoint for this point would be 0. If you look at B and D right here, the middle is right here in the center, 0. From A to B, what's my midpoint? Well, if I take -3 and I add -2, and then I divide it by 2, you're going to get a -5 over 2, which is equal to -2.5. So -2.5 is right in the middle there between those two dots. From B to C, you have a -2, plus you have a +1. Dividing it by 2. It's going to be -1 over 2, which is just -0.5. So -0.5 right here is my midpoint from B to C. Write a segment addition to model the distance between, or the distance from, model the distance points A, C, and E. So it's distance between points A, C, and E. I should have put the word between in there. So we got A and C, A to C right here. So you've got AC, plus you've got C to E. So C to E is right here. So C to E. And that's going to equal from A all the way to E. So from A all the way to E, we added the two together, and that's going to be equaling AE. Now AC, we could put down as 1, 2, 3, 4. AC is 4. So from -3 over to 1, so you get a 4. And CE, we've got 1, 2, 3. And then from A all the way to E, we should get a 7, which we did earlier. So there's your notes for today. Thanks, guys. See you tomorrow.